Hello everyone, today we'll talk about the problem minimum deletions to make string balanced. We're given a string consisting of letters A and B, and we have here a definition of a string being balanced exactly when there is no pair of positions ij, such that I is to the left of j, the letter on position I is a B, and the letter on position j is an A. And we want to delete the fewest characters to have the remaining string be balanced. Of course, one other way of looking at a string being balanced is simply that the string is sorted. So the minimum number of deletions for the remaining string to be sorted. And one other way of looking at it, since of course we have this balance definition, we have this string being sorted definition, and one other way of defining what we want is that we want there to be in a string some position between characters. So we have a string with characters. And of course, we're talking after the deletions. We want some position, maybe before the first character, maybe after the last character, maybe somewhere in the middle, such that everything to the left of it is an A, and everything to the right of it is a B. So I want to delete the fewest characters to have that be the case. That all the A's are to the left, all the B's are to the right. And it of course is easy to see how this is the same thing as the string being sorted, the same thing as the string being balanced. But when looking at the problem this way, it's very easy to know how we can actually tell what the smallest number of removals is, because we can easily tell what is the number of removals necessary to make sure that the position that we're currently looking at is one of the possible division points, or the only division point, as it turns out. So in essence, we can iterate over all those division points, and if we can calculate how many letters have to be removed so that everything to the left of it is an A, everything to the right of it is a B, then we can take the minimum over all those numbers, and that will be our final answer. And of course, it's easy to calculate it, because for this position on the left, the answer is just the number of A's to the right of it. So the number of A's in the whole string, because every A to the right of it is bad. And at the end, on the final position, it's the number of B's to the left of it. So whenever we step, so let's say from this position to this position, then this letter here can either be an A or a B. If that letter was an A, then before that A was a bad letter because it was to the right of our division point, and now it becomes a good letter. So the number of bad letters decreases by 1. However, if that letter was a B, then it was before to the right of us, so it was a good letter. Now it becomes a bad letter because it's to the left, so the number of wrong letters increases by 1. So we can just keep that in mind, keep the running count of bad letters, take the minimum over all of those, and that will be our result. So our result starts at the result for the left bound, which is just the number of A's. We go through all the positions and we look at the letter at that position. It's either an A or a B. If it's an A, it now becomes a correct letter, so we have one fewer wrong letter. Otherwise, it was a B, now it becomes a wrong letter, so the number of wrong letters increases by 1. The result is the minimum of those, and at the end we return the result.